Alright, so here's section 8, quadratic formula. And this is a biggie. You're going to use it a lot as you roll through the years in your math classes. And so what we need to understand with the quadratic formula is it is a formula. So once we figure out the key components here, which would be A, B, and C, once we know what these things are, we plug them into the correct spots on the formula, and when we do that, life just gets real nice. So what we want to do then is we want to learn how to handle this. Okay, so let's just start with a problem down here. X squared plus 3x equals 2. Notice that it's a quadratic equation. We can tell that because of the 2 there. But what we need to do is get it into standard form. So it needs to be equal to 0 over here on the right. Just subtract 2 from both sides. And then from here, identify what A, B, and C are. And A will always be the number in front of X. B will always be the number in front of, let's see, A will be the number in front of X squared, B will be the number in front of X, and C will be the constant. And once you do this, then you've got A, B, and C. Then we've got these places to fill. We've got A's, we've got B's, and then we've got C's. And we just plug our numbers into those places to get everything to work out. So what it ends up looking like is X equals the opposite of B plus or minus the square root of B squared. And always put that guy in parentheses. Minus 4 times A times C. All over 2 times A. Now the algebra's done. There's no algebra left. It's just going to be combining down what's under the radical and seeing if it's something that we can reduce out. In this case, it's going to be 9 plus 8 over 2. And this gives us, for this problem, negative 3 plus or minus square root of 17 over 2. And this is a good answer. And this is where you would keep your answer. Don't change it to decimal. Leave it exact. Okay, here's another example. And again, we're going to use the quadratic formula. And this guy actually just has one real solution. So the previous example we did had 2 real solutions, a plus and a minus. This one just has one. So if you look back here at our previous problem, notice that this thing would become negative 3 plus the square root of 17 over 2, or negative 3 minus the square root of 17 over 2. These are our 2 answers, okay? Well, look at this one. This time we're only going to have just one real answer. So again, what we want to do is get everything over so that we have standard form. Remember, standard form, ax squared plus bx plus c equals 0. Standard form. So subtract 12x from both sides and add 9 to both sides. So I'm going to end up with 25x squared minus 30x plus 9 equals 0. And from here, we figure out what A is, what B is, and what C is. And once we have these things, we just drop them right into our formula. And again, we've got A, we've got B, and we've got C. So we just put our numbers into the corresponding spot. X equals the opposite of B plus or minus the square root of B squared, and use parentheses, minus 4 times A times C, all over 2 times A. We'll get your calculators out because we're going to need to do a little bit of checking here. But what we're going to end up with is 30 plus or minus the square root of, now 30 squared is 900, minus, and then 4 times 25 is 100, times 90 is also 900. So if you're not sure, double check your calculator. And what happens is we end up with 30 plus or minus the square root of 0 over 50. Well, this is 30 over 50, which gives us 3/5. And here we're done. We have a good answer, and the square root of 0 is 0, so there's nothing weird or wacky going on that you need to worry about. Alright, so this guy then is going to be a quadratic equation with imaginary solutions. So this is the third different case. Notice on this case right here, the previous problem, when we got down to the bottom, we had just one answer. And on the problem before that, when we got all the way down to the bottom, we had 2 answers. So when you get an imaginary solution then, you're going to have 2 solutions, but they will not be real. So let's take the same steps that we took on the previous problems. Let's get a 0 on the right-hand side. Standard form. And then let's list off our A, B's, and C's. Alright. And then once we've got these guys, plug them into your quadratic formula. You put A in where A is, you put B in where B is, you put C in where C is. And then you simplify it out and see what you're left with. So when we do that, we're going to end up with x equals the opposite of b plus or minus the square root of b squared, use parentheses, minus 4 times a times c, all over 2a. So when you simplify this guy down, then you're going to have negative 4 plus or minus the square root of, well, look inside here. You're going to have 16 in the front minus 20. Well, what you're dealing with then is negative 4 plus or minus the square root of negative 4 over 2. Well, we've just talked about how to handle a situation like this. The square root of negative 4 is 2i. So we've got x equals negative 4 plus or minus 2i divided by negative 2. We're not quite done, but we're almost there. Notice that each of these terms, is divisible by 2, so we can reduce out a negative 2. So negative 4 divided by negative 2 is 2, and then negative 2 plus or minus negative 2 divided by negative 2 is going to be plus or minus 1. So our final answer here is this guy, and it's 2 answers. Why? Because I have 2 plus I and I have 2 minus I. If you have one complex number answer, you will have 2 complex number answers, imaginary complex numbers. So keep that in mind. Okay, now this is a little bit different. We're just going to look at the discriminants, just the discriminant, which is the highlighted part here. It's the part of the quadratic equation under the radical, and it's called the discriminant. It's called the discriminant, and there are 3 things that we can learn from a problem about the discriminant. One of the things that can happen is you have 2 real solutions. So if I were to graph this, it would be a graph that looked something like this. Because a solution is where I cross the x-axis. And where do I cross the x-axis? I cross the x-axis in 2 spots, right here and right here. Okay? The other thing that can happen is I can end up with one solution. What does that look like? Well, with one solution, I would have a graph that would just come down and just barely touch the x-axis. And it only touches at one spot. Where's that one spot? Right here. That would be one solution. And the last case that we could have would be one with two imaginary solutions. What's an imaginary solution mean? Well, it means we don't cross the x-axis at all. So we have a graph that looks like this. And notice that on this particular graph, there's nowhere that my graph touches the x-axis. So when that happens, I have imaginary solutions. Well, one of the things that we can do before we even get started is we can figure out and use the discriminant to determine how many solutions I'm looking for. So let's take x squared minus 8x plus 17. And on this guy, a is 1, b is negative 8, and c is 17. So do b squared, use parentheses, b squared minus 4 times a times c. And whatever this number is, if this number is going to be bigger than 0, we're going to have two solutions. Well, I'm going to end up with 64 minus 28. Or 68, sorry. So what does this tell me? Negative 4. So this guy right here, this problem matches up with which one of our options here. Okay? So basically, this guy's going to have no real solutions. Everything's going to be imaginary. Alright? Let's look at a different one. What about this guy right here? X squared minus 16. Well, hey, now what we're looking for now is if it's equal to 0, we'll just have that 1. So what would a be here? A would be 1, b would be negative 8, and c would be 16. So let's do this. B squared, use parentheses, minus 4 times a times c. And now I'm going to get 64 minus 64. Well, hey, guess what? This is going to give us 0. And that actually matches this middle guy here. So that one matches up. So that's excellent. That's what this one would look like. And then what about this last guy? So this should be 1 with 2. And we'll look at him. We'll do him in purple. So A is 1. B is negative 8. And C is positive 15. Alright. So b squared, use parentheses, minus 4 times a times c. 64 minus 60. This guy is positive, and so since he's positive, that means that he's going to have two real solutions. Okay? And that's how you can use the discriminant. And then once I know what goes under the discriminant, I've got this part of my problem now. So then it's not very hard to figure out the rest. So for this first guy, my discriminant is 4. So the opposite of b plus or minus the square root of 4 over 2. Can we figure this out? Sure. This is going to be positive 8, positive 8 plus or minus 2 over 2. What two problems am I working with then? I'm working with 8 plus 2 over 2 and 8 minus 2 divided by 2. So these are the two problems I'm going to work with. I get 5 and I get 3. My two solutions. And we know that from our discriminant. The second one, my discriminant is 0. So the opposite of b plus or minus the square root of 0 over 2. Well, what is this going to be? This is just going to be 8 divided by 2, which is 4. And then the last guy is going to be the opposite of b, plus or minus the square root of negative 4 over 2. And this looks like one that we worked just a second ago. This is going to end up being 8 plus or minus 2i over 2. And there's a 2 in all of these things. And so what does that mean? That means that we're going to have 4 plus 2i, 4 plus I, and 4 minus I. Remember, these imaginary guys occur in pairs. And that's all there is to it. So this discriminant is really a nice way to go through and look and check, do I have 2, 1, or no real solutions?